Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think yesterday we were discuss about the multiple choice question which are based on chapter number 2. The name of that chapter is the reactive methylene compound. And so far we have learned 39 multiple choice questions, and today we will continue the remaining multiple choice questions. Let's see here question number 39. Read the question carefully. Ethyl acetate when heated with sodium ethoxide gives dash dash, and options are given: ethyl acetoacetate, sodium acetate, ethyl alcohol, methyl formate. These are the options are given. Ethyl acetate when heated with sodium ethoxide, it is one of the named reaction that we have described during the chapter synthesis of acetoacetic ester or ethyl acetoacetate, or we can call it as a beta keto ester. This is the synthetic reagent can be achieved or can be obtained from ethyl acetate treatment with sodium ethoxide as a strong base. Two molecules of ethyl acetate condensed together, the resulting compound obtained is known as a ethyl acetoacetate or the beta keto ester, and this reaction is known as a Claisen condensation reaction, and therefore the resulting compound or the final product obtained will be the ethyl acetoacetate. So that is a answer. Now let us look at as a next question, that is a question number 40. Question number 40 here. Let's see here. Question number 40. Diethyl malonate reacts with diethyl malonate reacts with diethyl malonate reacts with acid chloride to give acid chloride to give dash dash. Options are A, ethyl acetoacetate, ethyl acetoacetate. B option would be acetoacetic acid, acetoacetic acid. C would be acetonyl acetone, and D would be succinic acid. These are the options are given. Read the question number 40 carefully. Diethyl malonate. Everybody knows the structure of diethyl malonate will be this one: ETO, then C double bond O, here CH2, C double bond O, OET, ET, and therefore it is known as, there are two ethyl group and therefore it is known as a di-ethyl malonate reacts with acid chloride to give, what it give, ethyl acetoacetate or acetoacetic acid or acetone or the succinic acid. When it react with acid chloride, the resulting compound will be obtained as acetoacetic acid when acid chloride, as we know that the structure of acid chloride CH3 C double bond O Cl, when treated with a strong base, it will give ETO C double bond O CH2, then C double bond O CH3. This acetyl group is introduced over here, then C double bond O ET, and after the hydrolysis and followed by decarboxylation, protonation, what you are going to get? CH3 C double bond O CH2 C double bond O, and here acid. So acetoacetic acid will be the right answer for this question. Now let us move on to the next question, which is question number 41. Let's see what is it. Question number 41 will be, which of the following compound, which of the following compound contain reactive methylene group, reactive methylene group, and the options are as follows. Ethyl acetate, A is a ethyl acetate, B would be acetoacetic acid, and C would be sodium cyanoacetate, and D would be succinic acid. Succinic acid. Now read the question carefully. What do you get? Which of the following compound contain reactive methylene group? You have to find out, and everybody knows the reactive methylene group, the CH2 group, which is flanked between two carbonyl group or two electron withdrawing group, and that type of the group are generally referred as reactive methylene group. And therefore, first of all, let us see the structures of each compound which are written here. Ethyl acetate, the structure of ethyl acetate will be this one, C double bond O, then O, ET. This is the structure of ethyl acetate. Acetoacetic acid, structure of acetoacetic acid will be this one, CH2 C double bond O, OH. sodium cyanoacetate, the structure of sodium cyanoacetate will be sodium cyanoacetate, acetate part will be C double bond O ET, here sodium cyanoacetate is a structure of sodium cyanoacetate, I think sodium cyanoacetate. Which of the following compound contain reactive methylene group? Ethyl acetate does not contain. Succinic acid, as we know that CH2 C double bond O OH, then CH2 C double bond O OH, and sodium cyanoacetate will be, I think, C double bond O Na, and here maybe as this is a sodium cyanoacetate. This structure is known as acetate, and therefore here ethyl acetate does not contain reactive methylene group. If you see, here are two, but they are not. So look at acetoacetic acid, that sodium cyanoacetate acetoacetic acid which contain as a, which of the following compound contain reactive methylene group? Here the CH2 group is present, and therefore only B is a right answer for this. So let us move on to the next question. Next question would be, let's see here, question number 42, and what is it? Let us see. Which of the following compound undergo Claisen condensation? Which of the following? Which of the following compound undergoes Claisen ester, undergoes Claisen condensation, undergoes Claisen condensation. Which of the following compound undergoes Claisen condensation? Question mark. And options are given here. A is this one, CH3 C double bond OH. B would be ETO C double bond O, then C double bond O OET. I think this is not the structure, only one OET, and C would be this one, CH3 C double bond O CH3 ABC, and D would be CH3 C double bond OET. These are the structures. Which of the following compound undergoes Claisen condensation? If you remember Claisen ester condensation, what are the starting material required for that reaction, which is a famous reaction So for that reaction, 2 moles of ethyl acetate is used with strong base such as sodium ethoxide. Carbanion is formed and that will be act as a nucleophile and it is attacking on the second molecules of ethyl acetate ethoxide can be used will be removed and resulting compound obtained is called as a ethyl acetoacetate or the beta keto ester. So here D would be the right answer for this question. Let us move on to the next, that is question number 43. Let us see what is it. Question number 43. Here the carbanion obtained after the carbanion obtained after deprotonation of diethyl malonate is well stabilized due to dash dash. Now the options are as follows. Number 1, minus I and plus R effect of carbonyl group. Minus I and plus R effect of carbonyl group. Carbonyl group. B option will be minus I and minus R effects of carbonyl group. C option would be due to plus R effect of due to plus R effect of carbonyl group and none of these. D would be none of these. See once again, the carbanion obtained after deprotonation of diethyl malonate is well stabilized due to minus I and minus R effect of carbonyl group. As we know that minus I and minus R effect are produced when there is a electron withdrawing groups are present, and that electron withdrawing group can be stabilized. That carbanion factor affecting the carbanion at that time, we already learned these kind of the concept in our previous classes such as T.Y.B.Sc. So this is just remember, B is the right answer. Let us move on to the next question. The next question would be That is a question number 44, I think so. Okay. The two molecules of diethyl malonate. Two molecules of diethyl malonate reacts with 1,2 diiodoethane to give dash. And the options are given here. A. Adipic acid, B would be succinic acid, C would be glutaric acid, and D would be acetoacetic acid. Once again, read the question carefully. Two molecules of diethyl malonate reacts with 1,2 diiodide to give adipic acid, succinic acid, glutaric acid, or acetoacetic acid. Let me show the acetoacetic acid structure here. CH3, C double bond O, CH2, C double bond O, and OH. Succinic acid, as we know that CH2, C double bond O, OH, and the CH2, C double bond O, OH. And glutaric acid, there will be a 3CH2 group in between. This is a dicarboxylic acid, C double bond O, OH. Here also C double bond O, OH is a glutaric acid. And adipic acid, the structure of adipic acid, there are 4 CH2 groups are present in between two carboxylic group. Here C double bond O, OH. So adipic acid would be the right answer for this question. Let us move on to the last question, that is a question number 45. Question number 45. Let's see here. Question number 45. Acylation of ethyl acetoacetate. Acylation of acetoacetic acetate acetoacetic acetate. Acylation of ethyl acetoacetate. Ethyl acetoacetate. Acylation of ethyl acetoacetate followed by hydrolysis followed by hydrolysis and decarboxylation gives decarboxylation gives dash dash dash. Options are A would be alpha diketone, B would be gamma diketone, C would be beta diketone, and D would be gamma delta diketone. So what do you think, which would be the correct answer for this? Alpha diketone, structure of alpha diketone will be R C double bond O, then C double bond O R. I am taking as general. This is a carbonyl group, adjacent is known as alpha, so this is alpha diketone. Gamma diketone, once again R C double bond O, then CH2 C double bond O R. This would be alpha, beta and gamma. At gamma position carbonyl group is there, and therefore that is a gamma diketone. And beta, absolutely here C double bond O, then CH2 C double bond O, then R dash. This is alpha and this is a beta. At beta position is there, R13 position, and therefore beta is the right answer. Delta diketone, once again R C double bond O, then CH2 C double bond O and R. These are alpha, beta, gamma and delta, and therefore here acylation of ethyl acetoacetate followed by hydrolysis and decarboxylation generally gives beta diketone, and beta diketone is a versatile synthon. Variety of the organic compound can be prepared by using that compound. So I think with this we have learned, we have studied all the multiple choice question, probable questions which may appear in your exam, how to solve that problems. Some of the trick I have given during this explanation, or some of the objective type of the question I have given, the justification how we are choosing as a correct option. So that type of the description we have discussed here, and in next lecture we will start the new chapter, and the name of that new chapter will be the rearrangement reaction. I think with this let us wrap up the today's lecture. Have a nice day. Thank you.